Fantastic. So, welcome to the September 2019 MITRE Tech Talk. Tonight we're going to be talking about how can you take the ATT&CK framework and apply that to cyber threat intelligence, and then in turn take that cyber threat intelligence and turn it into adversary emulation. So first, some quick introductions. My name is Connor McGee. I would focus primarily on adversary emulation as well as development. My primary role here at MITRE is on ATT&CK and ATT&CK evaluations team.
And then I'm Sarah Yoder. I also primarily focus on ATT&CK and ATT&CK evaluations, but I tend to focus on the cyber threat intelligence and red teaming side.
So tonight's agenda, we're going to start by going over what exactly is ATT&CK for those who are not familiar with it. Understand the core concepts and how information is actually brought into the ATT&CK framework. Then we're going to talk about how we can take the CTI that's part of ATT&CK, how we take ATT&CK and turn it and use it for cyber threat intelligence, and then finally use that cyber threat intelligence for adversary emulation. So this is obviously a very wide overview, but we're going to dive really deep into it, and let's take it away.
Great. So before we get into the details of ATT&CK, I like to start with David Bianco's Pyramid of Pain. Show of hands, has anybody seen this before? Good, okay. Well, just to go over it real quick, I think it shows a good depiction of that certain things are really difficult for defenders to detect. So up at the top where we have like the tough and challenging, that's where we're focused, the TTPs and tools. Whereas things like hash values are pretty trivial. Like that's easy to detect, but it's also really easy for adversaries to change those things. If they just change one bit in their file, then there's going to be a new hash value. So like that's pretty trivial for them to change. So I bring this up because I want to focus that ATT&CK is going to be looking at the tippy top of that pyramid. We're looking at the TTPs. So what is ATT&CK? So it's a knowledge base of adversary behaviors. This can help then with threat-informed defense. I almost like to think of it as a adversary like encyclopedia, right? There's a lot of information there about adversaries. Everything is based on real-world observations. We only reference publicly reported intelligence, so there's nothing classified, nothing secret in there. All of this information, you can go and look at the original references. It's free and open and globally accessible, so you can go check it out yourselves, attack.mitre.org. And last but definitely not least, it is community driven. If somebody has a contribution that they want to send in, attack@mitre.org is the place to do that, because we can't keep up with it ourselves. So let's break down the matrix view. Hopefully most people are familiar with this, but we'll just go through it pretty quick. So along the top there, I know it's really hard to tell, but along the very top row, it's currently in blue, are the tactics, and that's the adversary's technical goals. So for example, their goal is to gain initial access into your environment. Their goal is to then going to be laterally move, right, and so on. The white cells that you see up there are the techniques, and that's how those goals are achieved. So it's kind of getting a little more detailed. So if initial access was the goal, spear phishing attachment might be the way that they do that. That would be the technique. We can then further drill down. So we've done TT, and the P in that is procedure. And so here we have a couple examples, and this is what you would see on the website. A procedure for this might be ATT&CK sent an email with a malicious Excel file, and that would be a procedure for this. So this information is what you would see on the website. We have a description of the technique, so hopefully that the ones that maybe you haven't heard of before get like a little understanding of what that is. We also have what platforms it applies to, and then we have detection, mitigation, and data sources. And these are mainly, they're very high level, and they're to be used as a starting point to help detect and mitigate against these techniques. A lot of this is going to be highly dependent on your specific environment, but we hope that that's like a good starting place. And then we also have examples of groups that have used this given technique. Similar but a little different, we have our groups pages. Software follows a similar format, where again we have a description. Here we have associated groups. We recognize that APT28 does not mean or is not a one-for-one for Fancy Bear, because different organizations have different data. But we do feel like these are associated groups that have enough similar techniques that it makes sense to group them together for this. So then you'll see a list of the techniques that this group has been known to use. as well as software, and then references. So just kind of bring that back again, that please feel free to check us on our work. Like, go back to that reference yourself and see the original reporting that we got all this from. So here's a list of public attack resources. Everything can be, you can access everything from the attack.mitre.org page, but there you can find conference talks. We have our Getting Started pages. That way, if you want more detail on a specific area of attack, that's going to be your best place to go. We also have structured content. So we have a GitHub repository that has how to use attack structured content. We have helper scripts in there, and it's represented in sticks. We have our Attack Navigator tool, which is a helpful web interface that you can select different techniques, assign scores, merge layers, do a lot of different cool things there. We also have a video on how to use that more in detail through the website. And then we have our Cyber Analytics repository, and that hosts a whole lot of behavioral analytics that are based on attack techniques. So you can go there, and if you're trying to search for, we'll just use spear phishing again, there's different analytics there that you can run to try to detect that thing. Next, we have adversary emulation plans, our attack evaluations, and Caldera. I'm not going to get into these anymore because Connor's going to talk a lot more about this later. So when I said it was community-driven, like, wasn't joking. We've had really almost 100 people and organizations help contribute in some way or another. So if you feel like we're missing a really important ATT, or you focus a lot on any given like malware or something, you think you want that in attack, please feel free to reach out. We would love for you to contribute. So this is just to show kind of the impact that attack is having on the industry right now. So if you just search attack on Indeed's job listings, over 200 of them mention attack in their job description. So this is definitely something that's becoming really big and popular, and so we hope that this talk will make you more informed about it. So that was kind of just like a quick overview of kind of what it is. So how does information actually get into attack? So first we find reliable open source reporting, which I already went over. These are just a few examples. Obviously, we have a ton of different references. And from there, we want to find the behaviors in that report. So again, thinking either from that pyramid or thinking the matrix view, we're looking at the tactics, techniques, and procedures, kind of to get to that behavior. We don't care about IOCs and hash values, IP addresses, that kind of thing. Not that those aren't important, that's just not what our focus is. So how do you actually find behaviors in reporting? So here I have an example from ATT&CK, which is a ransomware. And I'm just going to look through, and anytime that the report says, that the Trojan or malware is doing something, that's normally a really good indication of that procedure. So, I mean, it starts off pretty easy on that first bullet, right? The Trojan obfuscates its executable code. So I'm just going to highlight that for now, and we'll map that to attack here in a minute. So when doing that, I like to start with the tactic, because that matrix can be a little overwhelming because there's a lot going on there. Whereas if you focus down by the tactic, you're really looking for, you have a 1 out of 12 shot at figuring out where that belongs. And again, just keep in mind, right, we're thinking of what the goal of that action was. So referencing that first bullet, it says the Trojan obfuscates its executable code, ... making it harder for researchers to reverse engineer, right? Okay, that sounds like defense evasion to me. So I'm going to go through this process for each one of these bullets. Some there's multiple, and I'm also going to do this for the whole report. From there, we can move on to the techniques. So since we've already picked the tactic, we have already narrowed down which techniques might apply to this. I like to do, either Control F on the attack page is normally a good way to match words, like obfuscate, that's a pretty good one. We also have a search bar on the attack to hopefully tie in some of these keywords to make it a little easier. But as somebody who does this a lot for the attack team, I will say it's very time consuming, and there's a lot of reading kind of between the lines. But all that hard work pays off, all that information gets put into the attack website, so this is what it would look like to everybody out there. So what can you actually do with all the info that's in attack? you can write detections based on that. And this is probably one of our most common use cases. Would be to figure out what techniques you really care about, and then come up to make sure that you have ways to detect against those. Similar, we have the assessment and engineering, so actually testing those detections that hopefully you just came up with. And this is where that attack navigator tool that I mentioned earlier is a really good place to kind of track your progress through that process. Connor's going to talk more about what you can do with adversary emulation. And then we also have threat intelligence. So with that, I'm going to kind of focus on the threat intelligence piece and just kind of go through one example of how you might do this for your own organization. So let's say you work for a business and you really care about Russian ATTs that are kind of all over the news right now, right? Hot topic. So we'll pick two APTs from that for this example. So I'll start with APT 28, which I've noted in yellow. We'll also pick APT 29, noted in blue. So when I overlap this, colors happen, right? And so green is where both of the groups have overlaps in techniques. I'll just highlight a few of those. So what does this tell us, right? Well, it tells us a few things. I think it tells you that if you care about those Russian APT groups, if you aren't covering detections for the areas in green, you're probably going to have a problem. So that's probably a really good place to start building out your detections. So now what? Now that we kind of have a list of techniques that we care about, we're going to go into how to actually build out adversary emulation plans to test that. But before we do that, we're actually going to take a 10-minute break, use the restroom. I was told 15-minute break. Oh, wait. Okay. I don't know. I was told to give you guys a break. Ian, what's the... Okay, so we'll come back in 10 minutes then. I think that puts us at 6:35, and we'll get into the adversary emulation portion.
Audio is live again.
Time with this. I'm just gonna sip my coffee, hang back a little bit. Yep, give it a second. Is this? Which one do I control? Yep, perfect.
Alrighty, so we're back. We got some snack. Got to use the bathroom. And so Sarah again just went over some cyber threat intelligence and how it applies in the ATT&CK framework. So now what? What do we do with this information that you've collected about an adversary that you want to emulate?
So,
adversary emulation. We'll start off with what actually is adversary emulation. It's a combination of red teaming and cyber threat intelligence. You know, it's intelligence-driven red teaming is what we say. It's a combination. So with red teaming, normally you have operations where you might want to you want to reach a certain end goal. You want to compromise a certain box. You want to compromise a domain control and enumerate X number of users. And you don't necessarily care exactly how you get to that end goal. However, with adversary emulation, we care entirely about that process. We want to know all the steps taken to get to that end goal. So part of this adversary emulation process, as Sarah fantastically pointed out and explained, is analyzing that adversary behavior. So knowing the tactics, techniques, and procedures that they use. We won't dwell too much on that because Sarah already did that. The next step would be to develop a methodology, building a step-by-step script of all the different behaviors we want to emulate of this adversary. After that, it's actual execution of this, going into the environment, going to the keyboard, writing out the commands that we've built into our script, and finally, looking at the results, a combination of our red teaming, blue teaming, doing a hot wash of, okay, where did we do well, where did we do bad, what did we miss, and how can we improve upon that? So that's what is adversary emulation, but why should we care about it? And there's a few reasons. First, it's identifying gaps. So after we've built out a methodology, how and execute that, do we have any gaps in our defenses? So if we built out an adversary emulation plan with all these known techniques, and we don't detect on 3 of those techniques that we've laid out, that's a problem. We have to fix that. Along the same lines is verifying the defenses that we know we have in place. So if we expect to detect on X, Y, and Z technique, are we actually detecting on that? If we're looking for some type of bypass UAC behavior, are we actually detecting that and alerting on that? Excuse me. Red teams, are we actually going back to before of normal red teams just looking to reach a certain end goal? They only care about compromising a host, and they'll do whatever it takes to get onto that box. However, with adversary emulation, it's a lot more structured. We know all the steps and techniques that the emulation team is going to be doing, and you can understand that a lot more thoroughly rather than getting a report from your red team of being like, oh, this one technique worked for me to get onto the domain controller, but you guys did a bunch of other stuff that kind of is not along the lines of the scope of the evaluation. Result prioritization. So this is essentially being able to look at all the activity done during the evaluation and being able to say, okay, well, our privilege escalation right now is not the best. We don't really have any defenses for known privilege escalation attacks, or at least known privilege escalation attacks associated with an APT that we're concerned about. So we have to focus on that and really beef up our defenses with that APT. So again, Sarah, fantastic job talking about cyber threat intelligence and ATT&CK. And ATT&CK is a fantastic resource for collecting all of these references about adversary behavior. So we can see here for APT3, which was the APT used in the round 1 for ATT&CK evaluations, which I'll get into later. We have a list of techniques that we can pull from inside of ATT&CK. Within this list now, we can pull out techniques that we think are applicable to our environment or our organization and build them into our adversary emulation plan. So now that we've taken out this list of techniques that we think we want to test,
how do we actually translate this verbiage that's on the ATT&CK website into something more testable?
It starts off with documentation.
It's first
knowing which techniques we are going to be testing, and writing about what those techniques actually do.
Excuse me. So, for example,
scheduled task. APT3 is known to execute scheduled tasks in this fashion. We have seen in the wild, through publicly available information, APT3
executing this specific command. So now,
what's important is to understand how exactly we want to execute scheduled tasks, though.
On the
left side, it's part of a built-in Windows command. We can run scheduled tasks on the box itself, and emulate that behavior that way. Or if we want to use a certain C2 framework like Cobalt Strike, we can use the built-in command that way with the shell command.
And ultimately,
it is the same thing between this one scheduled task binary. However, it's not the same in all the cases. How Cobalt Strike does some type of bypass UAC might not be the same as it is built into a Windows host that you might exploit. So it's part of understanding the techniques we want to emulate, breaking down what they do, and then breaking down even further into understanding how exactly we're going to execute that command on the box.
So now
that we've broken out all the techniques we want to test, you're going to repeat this whole process for all those techniques. You're going to build out the script of techniques and their commands associated with them.
Excuse me. And this is going to,
this might seem a little tedious, but it's extremely important, because before you even actually get hands on keyboard and begin your adversary emulation test, you need to know exactly what's going to happen. The blue team should have an idea of what's going on. The red team should know all the steps that's going to happen. That script that they've written out should be essentially flawless, and you should be able to copy and paste commands at the end of the day and execute your red team activity. So, hooray! You've finished an adversary emulation plan. Kinda. We've very high level right now, obviously, and you can definitely read our adversary emulation plan on the ATT&CK website right now. But there are some key points to talk about. Adversary emulation plans are not an exact science. It's a very loose process of being creative and understanding what the adversary can do and translating that into something that's testable in your environment. Every organization has a different structure. Certain organizations have different restrictions within their own environments, and you have to adjust for those, and that's acceptable. That's perfectly fine. You don't have to be completely confined to what's on the ATT&CK website or any other CTI that you've collected through other means. Another thing to point out is that there's no minimum number of techniques that you might need for an adversary emulation plan. You don't need to have, 2 techniques or 5 techniques from each of the tactics and then use all of those. You don't need to hit one technique from every tactic. That's absolutely not necessary. But something that is important is the order that you actually execute these. If we think about the adversary lifecycle, we'll start at initial access. Excuse me. We'll start at initial access. We'll do some lateral movement, try and escalate privileges, exfiltrate some documents that we might have found, and then maintain persistence. And that methodology applies for adversary emulation. Sticking to that, an actual adversary lifecycle is important. We don't want to just jump onto a box, attempt some privilege escalation that we know, whatever it means, and say, okay, well, are we detecting that or not? That's not adversary emulation. That's a red team activity, and that's perfectly acceptable for plenty of organizations, and should still be done if you want to test that. But understanding how an adversary does get initial access, how do they move laterally, and then how do they actually escalate privileges is just as important. That's something to keep in mind.
So, we've talked
about adversary emulation. We've talked about why it's important. But how have we at MITRE embodied this methodology for adversary emulation? And that's through the ATT&CK evaluations. And for those who are not familiar with ATT&CK evaluations, it's an initiative by MITRE to evaluate security products within the industry of how well they can detect against known adversarial behavior. What's important to talk about is that it's an open methodology. We completely release all of the results as well as the steps that are executed as part of the adversary emulation plan. You can go onto the website, attackevals.mitre.org, and you can read about the individual steps that were executed along every step of the way. It's across 2 days with 20 different procedures that were executed, and for round 1 it was 56 different techniques that we have tested.
And all the exact techniques aligned with all of the techniques used at each step is available there. It's also important to point out that the results of all the vendors and how well they tested, which for round 1 was 12, is also publicly available on the website. This includes detection notes explaining what they actually captured and detected on for our adversary behavior, as well as screenshots actually showing the proof behind these, showing the proof behind their detections. And this is important because we want to empower the end users. We want people to have an informed sense of what products they might be purchasing or using down the line.
So let's talk about
The actual evaluation process. Going back to the scheduled task, this is actually the exact command ran during one of the procedures of the attack evaluations.
You'll see it's the
Same exact command as noted within the cyber threat intelligence for APT3, and with a few caveats of, it's a different name and the actual executable is slightly different. In theirs it says test.exe, and ours we use one DL32 to launch another DLL file. And that's perfectly acceptable. Your adversary emulation plan, again, does not need to be an exact replica of your cyber threat intelligence. Excuse me. And that's reiterating the point of that it's not an exact science. It's up to you, however you want to emulate this adversary. So we ran this exact procedure for 12 different vendors in round 1 to see how well they were actually able to detect this. And this is one example that of a vendor
detecting the scheduled tasks, and you can see,
they saw the process create for SEH tasks.
They were able to see
the command line arguments for the scheduled task. And so they were able to successfully detect on this type of behavior, right? And we were able to repeat this process for all the vendors to see how well they all detected, right? And on the website, which this view is available on the website,
a tool that we have
called the technique comparison tool, which essentially is a drop-down of all of the steps that we ran, all the techniques that we executed, and you can compare all 12 vendors simultaneously for how well they performed at that step.
So what
I want to point out here is different vendors have different types of detections.
And it's not
Not to say one did better or worse, it's that they detected it differently.
For the
Attack evaluations, we do not rank or score any of the actual vendors. Rather, we assign a detection category, as you can see on the left side of the column here, such as telemetry, enrichment, general behaviors. And this just categorizes what the vendor is actually able to see during the evaluation.
So
I'm going to point out the attack evaluations website again because it's amazing. There's a lot of stuff behind the methodology that I have not gotten into here, but you can follow the complete operational flow, as we call it, and
excuse me, and
know exactly how we perform this evaluation and redo it inside of your environment.
There's
other things I mentioned, the tech comparison tool, as well as actual results of
different vendors. It's
very interesting to read through how well these vendors can actually do, and it helps the end users hold these vendors accountable to what they actually say they can detect. So I started getting into it very briefly at the end there. Well, how can you as an end user launch your own attack evaluation within your own environment, right? Well, that's where Caldera comes into play. And for those who don't know, Caldera is an automated red teaming tool built here at MITRE. That's completely customizable in the sense that you can include any type of command part of it, and it will execute
inside the environment.
So there's one. I'm not going to get too much into Caldera. It's going to be more focused on combine the two. However, there's one thing I do want to point out in Caldera. It's called adversary profiles, and what these are the actual
adversaries, for lack of a better word, it's the perfect term to describe them, of the different steps that are going to be executed.
So in here you can see that there are a couple different phases. In this screenshot I've only shown the first 2 phases. However, it's system network configuration discovery as well as system ownership discovery. And within those adversary profiles, there are specific commands associated with each of them that are going to be executed. So as Caldera runs inside of the environment, it's going to go through these phases, perform the commands listed inside of them, and then you'll get the results back. So just to make sure that was clear, how do we combine this with attack evaluations? Well, we are releasing an attack evaluations plugin for Caldera, and for those who are also not familiar, Caldera uses a plugin model where you can actually create your own plugin to load in to Caldera to do
whatever type of activity that
you're interested in performing.
And for us,
we want to obviously recreate the attack evaluations within Caldera itself.
Excuse me. Take a sip. So as you can see here on the bottom part of the screenshot, we have a couple steps that list techniques, right? And you'll notice the numbers on the side of them, 2A1, 2A2, and these link to the exact procedures that we ran during the attack evaluation. And excuse me. So what's useful about this plugin is that we can then load Caldera into whatever environment we're testing on, launch the adversary profiles associated with the attack evaluations, and essentially have our own attack evaluation in our controlled environment, whatever that is. And this is useful because, so yes, we did evaluate 12 different vendors for round 1, but what if there's a vendor that was not part of that evaluation that you're interested in seeing how well they do? What if there's a different configuration that one of the vendors we did test is using that was not part of our evaluation at the time? Also, what if there's some other type of detection you're trying to test against your team? You know, does your SOC actually defend against it? Does whatever AV you're using detect against anything that we've been doing through the attack evaluation? So going into a little more detailed, on the right side with the screenshot, you can see the results of an actual Caldera operation. And operations essentially just run those adversary profiles, and you have operations run multiple
adversary profiles, and I'm going to leave that. So again, going back to the 2A1 and 2A2 execution, you can see the actual commands that were run, cmd, waxc, arp, and ipconfig. These were the exact commands that were executed during the attack evaluation. And obviously, yes, these are a little more straightforward commands, but it's just to show the point of this is an exact replica of the attack evaluations. Also, it's important to point out that the cyber threat intelligence collected from here shout out to Anita, she's the best. Like so many things are here. Cyber threat intelligence. So, you might be asking, why did we run CMD, waxc, and then RBAY or ipconfig? Well, that's pulled from the cyber threat intelligence that we've collected about APT3. They have been known to use CMD, waxc, and then the command they actually wanted to run. And that's important part of the adversary emulation, because we want to stay as true to form with them, while still having the flexibility of performing what we want. Excuse me. So with the red arrow, point out there's a little star over there which you can click on to actually view the results of the adversary of the phase. And once you click onto it, you get the results of ipconfig. It's just an ipconfig output. It's obviously correct. It's simple network configuration information. So important takeaways of adversary behavior.
Yeah, I can.
Okay, I'll do. Okay.
So important takeaways. So today we start out by going over like understanding adversary behavior and why that's important, why it's important to move towards the top of that pyramid of pain and away from IOCs. We went over a little bit of where you can get this information, as well as how to find behaviors in reporting as well.
Yep. And also reiterate some of the important takeaways for adversary emulation. You can run different procedures for the same adversary. As Sarah pointed out, you do have a lot of overlap between them, and those techniques are not going to be the exact same thing. APT28 might execute bypass UAC differently than APT29 does, and understanding those nuances is important. Also, how to use an automation framework for easy testing. Everybody does need to evaluate their security, and finding an easy way to do that is important, and that can absolutely be done with Caldera. One thing I did forget to mention is that the attack evaluations plugin will be released by the end of this week, actually, on the attack GitHub, and pay attention to the attack Twitter for the announcement on that. There's going to be 2 separate versions of it, actually. There's going to be an initial one where it's a little more customizable. You can load Caldera into your environment, execute the plugins, and you'll be on your merry way. There's also going to be a version where it comes actually with Detection Lab, and for those not familiar with Detection Lab, it's a local environment that you can execute some type of malicious activity and detect on it. Inside of the Detection Lab, it comes with Splunk and a lot of other
defensive and detection software. And it's very easy to run simple command, go search for it in Splunk and see how well you can do that. So it's important for actually hunting for the behaviors. And part of the evals plugin will come with Detection Lab, and you'll load the plugin, start everything up, and it will spit up a Detection Lab instance for you on your machine. Just want to make sure I pointed that out.
So with that, we're actually done. Up here is all the ways that you can contact, stay up to date with everything that's going on with ATT&CK. At this time, we have time for questions. If anybody has any
questions.
Start with you.
Sure.
So the question was what the threshold is for seeing a technique in the wild for it to actually make it into the ATT&CK website, right? Or, mm-hmm.
As part of the references on the groups page.
Yeah. So we don't necessarily have a threshold in that for like that specific use case. So for example, if vendor, FireEye, CrowdStrike, pick your poison, mentions that APT28 uses a technique, we will go ahead and add that to their page. But one way to note how often we're seeing that technique would be the references. So at the end of each example of the technique, it might have 3 references or 4 references, maybe 1. So that might help you gauge kind of how frequent we are seeing that. And then for software and malware, we have kind of a threshold roughly of we have to have about 3 references for that to go onto the site. Yep. So just to repeat your question, we do not put anything on the website that hasn't already been published by somebody else. And that's mainly because of the position MITREs, and we aren't collecting data on APTs and malware in that sense that some of the bigger vendors are. I think I saw a question over here.
CVE?
No.
KPEC? Oh, I don't know about KPEC to answer that authoritatively.
I'm happy to talk offline with you about that. No, I don't believe so, but I'll get you more information and we'll follow up with you in a minute.
I do know that we at least, we do have a relationship with KPEC at least, and we do have references on the ATT&CK website to how KPEC and ATT&CK fall into each other. Any other questions?
So this framework covers understanding and emulating adversary behaviors, but is there best practices or mitigation techniques embedded in the ATT&CK framework? Talking about preventing adversaries like between steps, or is there like a certain
So on the techniques page, for any of the techniques, there are mitigations listed of how to actually prevent against those. Oh, and the question was, for all these techniques, is there a way to, how do we mitigate against certain techniques? And they're all listed on the techniques page. Yep. Yep. So right now it's EDR products right now. So for example, it was some of the vendors from round 1 were CrowdStrike, Endgame, Carbon Black, just to name a few of them from round 1. And again, those are EDR products. And for round 2, which is actually currently happening right now, we are evaluating 21 vendors, some from the first round and some completely new. Yes. So most of them are EDR. Some of them are not necessarily EDR. It depends on, I guess, how they like to sell themselves. But for the most part, EDR. Yep.
Are you mapping any of the mitigations against any of the frameworks out there, NIST or anyone else?
So the question was mitigations against NIST. I will say it's in progress, and follow us on Twitter and the blog for an update on that. Anything else? So I think that's it. We'll be hanging out for a little while if you do have any follow-up questions. I think there's still probably some cookies out there, and we do have stickers if anybody wants a sticker. So with that, thank you.